Welcome back to Mr. Ace Math. This lesson's on prime factorization. Some stuff you should make sure you know before you begin this lesson are what prime numbers are, what factors are, and how to use exponents. So make sure you know those and let's get started. Well, first of all, let's think about the words prime. A prime number is a number that has only two factors, one and itself. Factorization. In the word factorization is the word factor. And a factor is basically just a number that divides another number. For example, the number 20 has 1, 2, 5, 4, 10, and 20. Those are all factors of 20 because all of those numbers can divide 20. So prime factorization is just putting those words together. It's a simplifying of a number down to its prime factors. So let's take the number 45 for example. Well, we can break down 45 into 5 times 9. Because 5 times 9 gives us 45. Well, this branch here, the 5, is already prime, so we're done with that branch. But the 9 is not broken down to its prime factors yet. Well, what can break down 9? Well, 3 can divide 9. 3 times 3 is 9, so those are our factors for 9. Since 3 is prime, both of these branches are done. And it's important to know that this here is actually our factor tree. That's not our prime factorization. A factor tree is used to help us find the prime factorization, but it's not the prime factorization itself. So the prime factorization is the list of those prime factors. So it's basically 3 times 3 times 5. But we could actually rewrite this using exponents because 3 times 3 is actually 3 to the second power. So it's going to be 3 to the second power times 5, and that is our prime factorization. So what about the prime factorization for the number 100? Well, I want you to make sure you understand one thing very clearly. It doesn't matter how I start breaking down my numbers. In the end, the prime factorization will be the same exact thing no matter what numbers I use. So let's break down 100 using 2 times 50. We could have used 4 times 25. We could have used 10 times 10. Either way, we're going to end up with the same prime factorization. But let's use this. 2 is already prime, so we're done here with this branch. But what about 50? Is 50 prime? No. We can break it down using 5 times 10. The 5 here is already prime, so we're done with this branch. But the 10 is not. And we can break down 10 using 2 times 5. And since 2 and 5 are prime factors, we're done. And that will give us our prime factorization. Our prime factorization will be 2 times 2 times 5 times 5. And one thing I want you to notice, you may have noticed it from the last problem, even though I have 2 times 5 times 2 times 5 up here, remember, in multiplication the order doesn't matter. And I actually prefer to put the numbers in order from least to greatest. So I put 2's first and then 5's. Now, is there any way to rewrite this using exponents? Yeah. 2 times 2 is actually 2 to the second power. And 5 times 5 is actually 5 to the second power. So I can rewrite this as 2 to the second times 5 to the second. And that is my prime factorization. How about the prime factorization for 99? Well, let's break 99 down. How can we do that? Well, we could break it down using the numbers 9 times 11. Well, the 11 is already prime, so we're done with this branch. But is 9 prime? No. So we have to keep breaking it down. How can we break down 9 into its prime factors? Well, 3 times 3 is 9. And since 3 is prime, now we're done. So our prime factorization is 3 times 3 times 11. But can we rewrite this using exponents? Yeah, because 3 times 3 is actually 3 to the second. So our prime factorization is 3 to the second times 11. And what is the prime factorization of 350? Well, let's find out. Now remember, we could use any factor pair of 350. In other words, we could use any two numbers to break down 350 we want, as long as one of those is not 1. Remember, you can't break down 350 times 1 because 1 isn't prime. So how can we break down 350? Well, let's use 35 times 10. And I actually want to start with 10 because it's a smaller number. Well, how can we break down 10? Because 10 is definitely not prime, so we can break it down using 2 times 5. And 2 and 5 are prime, so now we're done here. But we're still not done with 35. And how can we break down 35? Well, we could use 5 times 7. And since 5 is prime and 7 is prime, we're officially done. There's nothing else left for us to factor. So our prime factorization is going to be what? Well, remember, I like to start from the lower numbers, so we'll start with 2 and then end with 7, and just list our numbers. So we've got 2 times 5 times 5 times 7. And is there any way to rewrite this using exponents? Yeah, because 5 times 5 is 5 to the second. So let's rewrite that, and our final answer is going to be 2 times 5 to the second times 7. So here's your pause and practice. Just pause and practice. When you're done, unpause the video. After a 3, 2, 1 countdown, your answers will be displayed. Go. So let's go over our answers. Number 1 is 2 to the second times 3 times 11. Number 2 is 2 to the sixth. Number 3 is 2 times 37. Number 4 is 2 to the second times 3 times 5. And number 5 is 2 to the second times 13. So let's review this lesson. A number with only two factors, which are 1 and the number itself, is called a prime number. A number that divides another number is called a factor. Breaking down a number into its smallest prime factors is called prime factorization. The diagram used to help you determine the prime factorization of a number is called a factor tree. True or false? If you break down a number using different numbers, you will get a different answer each time. Basically, like I said before, if you had the number 100 and had to find the prime factorization, if you use the numbers 2 times 50 instead of 10 times 10. Basically, what this is saying is that you would get a different answer each time, and that is simply not true, so that is false. You're going to get the same answer every time, no matter what numbers you use. You can never break down a number into its prime factorization using the number 1. Remember, you can't use 1 when you're finding the prime factorization, simply because 1 isn't prime, and all it's going to do is give you your original number times 1. You're not making any progress like that, so never use the number 1 ever. In the prime factorization, if a number repeats, you can write the prime factorization using exponents.
Don't forget to like, share, and subscribe.
And thanks for using Mr. Ace Math. Don't just pass math, ace it.